Criterion B. So this section has 2 questions. Answer all questions. Question 1, investigating patterns. In this task, you will use logic to investigate the relationship between slope and the y-intercept. Will be assessed using criterion B, which is investigating patterns, and criterion C, which is communication. Describe patterns and general rules created from system of linear equations. The images below represent the graphs of linear equations with every stage. The y-intercept and the slope of the graph changes. So you have stage n is equals to 1. You can see the y-intercept there is 2. For stage 2, the y-intercept is 3. For stage 3, the y-intercept is 4. So write down the missing values in the table. So we saw that we started with 2 for stage 1. So we started with 2 for stage 1, then 3 for stage 2, 4 for stage 3. So you have to the up to the 3rd stage, and then for slope. So we'll start from where the y-intercept is. The y-intercept is at 2, and then look for any point on the line. For example, I can look at this point. This point is on the line. So I'll check how far do I go up to this point through running and rising. So I'll rise once and then run once, and then I reach my point. So because gradient is rise over run, I'll only have 1 over 1. So the first slope is 1. So write 1 here. Half for stage 2, let's look at the slope for stage 2. So while I'm at this point, I can look for another point on the line, maybe this point. You can choose any point that is on the line that you're able to actually use the scale given for an exact value. So I'll use this value here. So let me see how much do I rise and run to reach there. Now from 3, the y-intercept, I'm rising 1, 2, 3, and then I run 1. So 3 over 1 is 3. So for stage 2, the y-intercept, the slope is 3. The last stage, the y-intercept is 4 here. And let me just, let me expand it. The y-intercept is 4. And choose any other point on the line and see how you can use that to rise or run. So for example, I'm choosing this point here, which is on the line. This one you can read the scale, so you can choose any point. So let's see how much do I fall down and how much do I run on the left up to this point. So I'll fall 1, 2, 3, 4, 5, and then I'll go to the left or run to the left once. So from here, I'm going once here. So when you fall, that is -5. Then when you go to the left is -1. When you go to the right is +1. To the left is minus, because x is minus on the left of 0. So -5 divided by -1, that is 5. So we're going to cancel that. And then we write 5. So from what you have here, you can see the patterns. For example, for y-intercept, it is 2, 3, 4. So the next number is 5. And then for this other case, it's 1, 3, 5. So I'm saying we are adding by 2, 2. So 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. So completing the table, for writing the missing values, you score B4. Okay, describe in words the patterns followed by the y-intercept. So you will say, starting from stage n equals to 1, the y-intercept increases by 1, starting increases by 1 starting, where do we start? We start at 2, starting from 2. So write that, then score your answer or your marks. Describe in words the patterns followed by the slope of the graph. So starting from stage 1, starting from stage n is equals to 1, the slope increases by 2, starting from 1. You can also say the slope follows an odd number pattern starting from 1. So you can really see those are odd numbers. 1 is an odd number, 3, 5, 7. So that's how odd numbers are written, and you can see that as a pattern. So 3.4, write down the general rule for y in terms of n. The easiest way to always have a rule is to consider the stage number and that parameter and treat them as points. So because we will have a constant rate of change, we can treat them as points and then write the rule in form of an equation of a line. So we all know that the equation of a line will be given by y is equals to mx plus c. But now because you are not comparing y and x, you are comparing y now the intercept, not c now. So we will start, let me just write, we are comparing capital Y and stage n. Stage n. Now we will not be comparing the variables y and x in terms of coordinates. We are comparing capital Y and stage n. So it is the same thing. The capital Y will be our dependent variable, then m will be independent variable. Where the x is, we put n. So we are going to pick 2 points. For example, I'll pick 1 and 2. That's the first point, and also pick 2 and 3. So we'll treat these as something that has constant rate of change and pretend we are calculating the equation of a line, and that one will give us a rule. Now, what we need in our equation, we need m. M is the slope. So what is the slope using these two lines? The slope will be change in y divided by change in x. Change in y, there is 3 minus 2, divided by change in x, there is 2 minus 1. And when you solve this, you'll get 3 minus 2 is 1, 2 minus 1 is 1, and you subtract, you only get 1. All right, so finally we'll have your equation as y is equals to mn. M is 1, so we'll just write n and then plus c. We also need to calculate c. C will be like the y-intercept using any of these points. For example, if I use point 1, 2, when y is 2, so where this y I put 2, n is 1. So when y is 2, you can really see it from the table. When y is 2, n is 1. So that is what I'm going to use here. So y is 2, n is 1 plus c. So we are calculating c. C at this point will be, take 1 to the other side. It will be 2 minus 1, which is 1. So our equation was saying y is equals to n plus c, and our c is 1, so it will be n plus 1. And you are good to go. So you insert there. And here you would have written your general rule for y in terms of n. Then write down the general rule of s in terms of n. We are going to use the same drill because it represents a constant rate of change. So all constant rate of change will have this form of equation, y is equals to mx plus c, only when they are linear. So, and this is what we have learned, all constant rate of change will have a linear model, will be represented by a line. So for this case, our dependent variable, instead of it being y, it will be s, because we are writing s in terms of n, and our x here will be n again, one more time, plus c. So I'm going to choose 2 points on the line, or 2 points on that relation. So when n is 1, s is 1. So I'm going to choose 0.11. And also I'm going to choose another point. You can choose any 2 points randomly. When n is 2, s is 3, like that. So our rule asks us to find m, which is the slope, which will always be changing y over change in x. Change in y for this case is 3 minus 1 divided by change in x, 2 minus 1. So the change here in y is, change in y is 3 minus 2, which is 1, and change in x here is 2 minus, no, it should be 3 minus 1, not 3 minus 2. So 3 minus 1 is 2, divided by 2 minus 1 is 1. 2 divided by 1 is just 2. You will come and write your relation. S is equal to m, which is 2, n, then plus c. We have to calculate c, so pick any point on the relation. For example, I'm picking 1, 1. So when n is 1, s is 1. So s is 1. So s is equals to 2 is 1 also. So it will be 2 times 1. Close your bracket, then plus c. So if you solve this, it will give you that. And then if you calculate c, the value of c will be, take 2 to the left-hand side, and you'll have 1 minus 2, which is minus 1. So c is minus 1. So we can write our relation, which was s is equals to 2n plus c, but c is minus 1, so you write minus 1. So you have written that relation, insert it, and you will have it written there. Verify your rule for s. I thought verify your rule for s, so 3.6. So how do you verify? You only verify by first writing your rule, which is s is equals to 2n minus 1, and then use a value in the table that you yourself obtain. For example, on this table, we were given stage number, and then we didn't have any value for the y-intercept or the slope. So choose any value. For example, I can choose n is equals to 4. So we come down here and say when n is equals to 4, s will be equal to, so we'll say 2 times 4 minus 1. So 2 times 4 is 8. 8 minus 1 is 7. So s is equals to 7. So let's check. When n is 4, is s 7? 4, 7, correct. So you'll say ends verified as seen from the table. Once you do that, that is correct. We are going to question 2 now. In this task, you will use relationship to investigate the formation of triangular patterns. Will be assessed using criterion B, which is investigating patterns, and criterion C, which is communication. Apply the concept of similar triangles, describe patterns and general rules for the placement of ladder against the wall. So the question is, a ladder is resting on the wall such that its top end is 12 meters. So check AB, resting on the wall. 12 meters above the ground. So D is a reference point in the image from which the height perpendicular distance is measured from the ground. So this is a reference point. So maybe this is a very large tall ladder and you can't measure. So you have to have a reference point. They have said this are perpendicular to the ground. So this one automatically makes a right angle triangle. Calculate the value of h in the above image. So we are to use we have to compare triangle ABC, ABC, and EDC, EDC. Okay, so this is a concept on similar triangles. So I can choose to say, I can choose triangle ABC and say AB divided by SE should be equal to, that is for the larger triangle, the smaller triangle, because they are similar by RHS, right, hypotenuse and side, AB over AC will be equal to, what side is similar to AB? It is side DE or ED. DE divided by which side is similar to AC? It is side EC for the smaller triangle. Okay, what is AB? AB is 12. And what is AC? AC is 6 plus 9, which is 15. It's equal to, let me delete that and put equal to, DE is what? DE is H, what we are calculating, divided by, so small h, divided by EC. EC is 9. So H divided by 9. So if you want to get H here, you have to multiply 9 on this other side. So you multiply 9 on this other side so that it removes the 9 down there, so that you will get H is 9 times 12 over 15. 12 over 15. So you can insert this, and then you can come there, because if you don't have access to your physical calculator, you are going to use this calculator here. So you'll press calculator, and then you'll do 9 times 12 over 15, and you get 7.2. Then you can come here and you can comfortably say copy. You can comfortably say copy from calculator. Wait for it to copy, and your answer will be 7.2. All right, so come down here. The ladder of different heights are rested along the wall with different stages. The distances AE and EC for all the ladders remain the same. Where is AE? So AE and EC remain the same, okay? And then the table below shows the perpendicular height of point D for ladders in different stages. Stage number N, 1, 2, 3, 4, 5. Then height from the ground to the top of the end to the top end of the ladder, which is point B. So from the ground, point A to point B. So we are starting with 12 and then goes to 10, 8, 6, 4. Then height from the ground to point D. So height from ground to point D, this point, so point ED. So write the missing values in the table. All right, so we have calculated that when the height from point A to B is 12, H will be 7.2, the answer we've gotten here. So we can comfortably write, when we have a pen to write that. So we can comfortably write that this is 7.2. So check the pattern from 7.2 to 6. What is the difference? You will subtract 7.2 minus 6, you get 1.2. Confirm that that difference is the same everywhere. So this is 1.2. Check the difference on this other side. What is 6 minus 4.8? It is 1.2 also. That means all the numbers here will be decreasing by 1.2 because you are moving from 7.2 to 6 to 4.8. So we'll have 4.8 minus 1.2 and you'll get 3.6 here. And then subtract another 1.2, you're going to get 2.4 at this point. So that is what the pattern gives you for the height. So there's no need of calculating again. Just see the pattern on the that is happening on the table, and you'll get your 3 marks. Allow me to keep these numbers in mind. So 7.2, 3.6, and 2.4, and so that it cannot overlap the screen. So let me cancel this and move down. So we can write them here. So I can put a table. What by what? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 6 is here. So you're not required to put a table, but you can put a table when you want, so that you can follow through 1, 2, 3, 4, 5, and then let's say this is the distance AB, because it is the one starting from 12, then 10, then 8, then 6, then 4. And then this is the height H, small h. Starting from, we said the first height was 7.2, the second height is 6, the third height is 4.8, the fourth height is minus 1.2, that should be 3.6, and lastly 2.4. Okay, so do this, make a table, and you get your answer. If it is editable, you can edit like the table we did up here, but if it's not editable, you can make your own table down here. Describe in words the pattern for H. So the pattern for H will say that starting from H n equals to 1, the height H decreases by 1.2, starting from 7.2. Then that's correct. Then write down a general rule for H in terms of n. So the same thing we did for up there. We are going to treat this as a as a linear system, meaning that it has a constant rate of change, and therefore we can treat that as a linear equation. Y is equal to mx plus c. But because we are comparing small h and n, so we'll write h is equal to mn plus c. So we will calculate m, which is change in x and change in y divided by change in x. I'm going to choose 2 points. I'm choosing 1 and 7.2. You can choose the one you want. And also I can choose the point 2 and 6. How do you calculate m? M is equal to change in y. Change in y will be 6 minus 7.2 divided by change in x. Change in x will be 2 minus 1. So 6 minus 7.2 is minus 1.2 divided by 1 is just minus 1.2. After you've gotten your m, you can write your h is equal to m is minus 1.2 plus c. So we need to calculate c, use a point on that relationship, which is 1 and, let me use 2 and 6, quite easy. And then when h is 6, look at the table, when h is 6, n is 1. So h is 6 is equals to negative 1.2, always use a bracket there, times n. So when h is 6, n is 2, so times 2, close the bracket, then plus c. All right, so this is 6, this is equals to negative 1.2 times 2 is negative 2.4, and then plus negative 2.4 plus c. Make sure you make c the subject at this point by moving 2.4 to the left hand side. If you move it, it will change the sign. Then it will be 6 plus 2.4, which will be 8.4. You really have to be good with mental math, and it comes by practice. By practice, practice, and practice. So h is equals to negative 1.2 n. Let me put n, we forgot an n up here. Negative 1.2 n plus c, and c is 8.5. So that is the relationship between h and n. So h in terms of n, that is the relationship. Then verify your general rule for h. So how do you verify? You come to the table, use a value that you have generated yourself. For example, we can use 4 and 2.4. Let's see, when n is 5. So we can write our rule is h is equals to negative 1.2 plus 8.4. Then when n is 5, when n is equals to 5, h will be equal to negative 1.2. So let me use the bracket, negative 1.2 times 5, then plus 8.4. All right, so h will be equal to negative 1.2 times 5 is negative 6. Then negative 6 plus 8.4 will give us the value of h, and now what is that? That is 2.4. Negative 6 plus 8.4 is 2.4. Let's see, when n is 5, what is small h? When n is 5, small h is 2.4. Then we have verified. So you'll say n's verified as seen on the table. As seen on the table above. So that's it for criterion B. Thank you.